2018, question 3. Anytime I have a graph of a derivative problem, I chart out what it says before I even get started. Now, this doesn't have to be the first thing you do, but usually you end up needing to think about it either way. Now, the name of this graph is G, so I'm going to write the name of the graph that I see. I'm going to make a number line for whether it's above or below the x-axis with positives and negatives. And for this one, I'm going to need to have some intervals of 0. I'm beginning at x equals -5. I am underneath the x-axis until I reach x equals -1. Then I am on the x-axis. I am 0 for an interval of time until I reach time 0. Then I am above the x-axis until I reach 4, but I bounce right back to above the x-axis until the time frame ends. The next chart that I will make is for the slope of the given graph. So I'm going to name it G prime. And now I'm going to focus on, is the graph heading up or down? If it's flat, then I'm going to have an interval of 0 written, starting at -5. And again, I'm focused on slope. I'm starting off with it being flat, a 0 slope until I reach -2. Then it heads up until -1. It is flat until 0. It heads up until 1. It is then flat until x equals 3. Then it goes down. I'm going to need to move this over a little bit. It goes down until I reach x equals 4, and then it goes up the rest of the way, and I reach my final time 6. I want to read very carefully about who has a relationship with who, in what way, and clarify that within my notes that I just wrote. This is the graph of a continuous function g. G is the derivative of the function f. Be careful and think about it. G is the derivative of f. So now I'm going to come back over to my charts, and I'm going to label them also with the other function's name. So the chart that I made G for is also telling me about when f prime is positive and negative. My G prime is telling me about the second derivative of f. And I've clarified that. I read over the rest and see that I know that G is this piecewise function from -5 to 3, and it's only a bunch of linear lines. But once I go from 3 to 6, I'm focused on this specific equation, and I look at the graph and I go, yep, that kind of matches from 3 to 6 for that parabola. Now that I've really spent some time looking at and identifying what my information is, now I look at part A. If f of 1 is equal to 3, what is the value of f of -5? So I want to look at this core relationship here. I want to know values of f, and the graph that I am given is actually the graph of f prime. Now, if I integrate f prime from a time a to a time b, the fundamental theorem of calculus says that the integral of this f prime is f. I plug in b minus I plug in a. So I wanted to put that out there, that I'm using the fundamental theorem of calculus. Now I'm going to look back in part A, and I'm going to see that it told me what f of 1 is equal to. And it wants me to find what f of negative 5 is equal to. The 1 and the negative 5 are x coordinates. And if I allow those to be my a and my b, then, then I'm going to be able to find f of negative 5 as one of these two expressions. Now, putting things in proper order, for a and b, I'm going to have it go from negative 5 to 1. That means that this is equal to f of 1 minus f of negative 5. I was told that f of 1 was equal to 3, so I'm going to put that information down. I need to find f of negative 5. And now the last piece is solving this integral. Now, due to the things that I wrote down, I can see that f prime, the integrand here, is the graph of this function that I see. If I am solving from negative 5 to positive 1, the integral of that graph, then I'm doing area and I'm considering above and below the x-axis. From negative 5 until I reach positive 1. Everything in between. I'm going to break it down to a square that is a 3 by 3. The area is 9, but the integral will read it as negative 9. A triangle that is a 3 by 1. Underneath the x-axis, area of the triangle is 3/2. I have no area in here, and then above the x-axis I have a 2 by 1 triangle. So I'm going to add that area because it's above the x-axis, and with a 2 by 1 triangle the area is 1. And now I'm going back to the equation. That means negative, no, let me actually find this number. Negative 10.5 plus 1 is negative 5.5. So negative 5.5 is equal to 3 minus what I was trying to find. I'm going to add f of negative 5 to the left. Then I'm going to add 5.5 over to the right. And that is giving me 8.5 is the value of f of 1. Or, sorry, f of negative 5. Now I want to go back and look at the question, make sure that I actually answered it and gave everything that they asked for. All it's asking me is for the value of f of negative 5. So that's all I needed to do. Now I'm going to grab the answer and bring it over real quick.
Ms. Blanchard?
Yes.
You messed up your addition.
Ah, fantastic. I do that sometimes. This addition, this is what the addition should be. And let me compare it. Yeah. No, stop. Okay, I'm experiencing lag time right now. What are you doing and why won't you listen and cooperate? There we go. Okay. Let me see. Does anyone see where the addition is?
It's the orange right under the second number line.
Right here? Let's see. So this is correct, but I added incorrectly. Yes, I did add incorrectly. Oh. Oh, hey, what incorrectly? No, we all make mistakes. So really, it's negative 7.5. Is that correct?
Negative 9.5.
Now you can tell your parents, my math teacher can't add. Oopsies. All right, instead of you trying to deal with that, there's the correct answer. Boom. Realize that you needed to express where this was coming from with the equation. You don't want to just drop numbers out of the sky. You want to let them know where the numbers came from. So any way that you wrote the fundamental theorem of calculus is good. Okay, moving on to part B. If you need me to wait, say something out loud. I'm going to erase some of this work to get it out of the way. I'm going to rewrite, though, the relationship that f prime is equal to g. Make sure to clarify that for myself. All right, part B. I am evaluating the integral from 1 to 6. This is the graph of g. That's my integrand, so I'm just flat out doing area, normally at least. I would flat out do area. I'm going from x equals 1 to x equals 6. However, without using the equation of the parabola, I'm not going to know this area unless I actually solve an integral. When I go to solve this integral, I need to split it up as being the integral from 1 to 3, where I'll find the area under the curve. Lag time, stop. It stopped. Oh my gosh, this is killing me. All right, so I'm erasing. Listen to me. Oh dear. My lag time right now is just really, really bad. All right, here we go. So this one I'm going to have to solve by knowing this as a function. My integral from 1 to 3 is a 2 by 2 square above the x-axis. The area is 4. So I have 4 plus the integral from 3 to 6, where the integrand is 2 times x minus 4 squared. Now, my job is to solve this definite integral by hand. Easiest way through it is going to be through a u substitution. Du dx is 1, so that means that du is equal to dx. And so I'm going to replace my x minus 4 with a u and my dx with a du, and then I'll be ready. Well, no, I won't quite be ready yet. I'm also going to change the 3 and the 6. When x is equal to 3, 3 minus 4 gives me negative 1. When x is equal to 6, 6 minus 4 is 2. Now I'm ready, and I can just solve this without looking back. So I have 2u cubed over 3. When I plug in 2, I'm getting 2 cubed minus negative 1 cubed is negative 1. And I would leave my answer here and not do any more arithmetic and risk the making a mistake. And I'm going to show you the answer. There we go. And so you can see that if you do the arithmetic correctly, you should be getting 10. You get the answer point once you reach what I'm going to cross right here. And you see the importance of writing out the integral you are solving, explaining what you're actually doing, and then going through with it. Okay. Unless you say something else, I'm going to move on to the next piece. I should always double check. Did I actually answer what it asked me to answer, and did I answer everything? And yes. I'm going to erase some of this. And now part C. All right, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. I'm going to actually start with the reason. So if f is increasing, looking at this relationship right here, f is increasing when its derivative is positive. Trying to make sure that lag time does not mess things up. And when I go to look at the graph, I am looking for when g is positive. Now, maybe I don't need to write down above the x-axis, but I'm just writing that down to point out that that's what I'm looking for if I'm looking for f prime being positive. I need to make sure that I explain this relationship between f and g, and then it's looking for this right here with the connection. Then I'm also looking for when f is concave up. So I'm going to write down f is concave up when f double prime is positive. And what does that mean about g? F double prime is g prime. So what that means is I'm looking at when the slope of g is positive. Now, for me, I prefer to not look at the graph, but to look at what I charted out. So I'm focused on finding these two things. I go back to the graph, and I start with where is f prime positive? Oh my gosh, the graph got messed up when I moved stuff around. Wonderful. Okay, so my chart's all messed up. Normally I would use my chart, but what I'm going to do is I'm going to look for where is the graph above the x-axis. That's my first question. Boy, come on. There we go. Above the x-axis is occurring for this x interval. Then I also want when it has a positive slope. So within that interval and having a positive slope would be here. Thank you, lag time. And here. So my answers are my open interval from 0 to 1 and my open interval from 4 to 6. Had I still been able to see the chart that I had charted out, then I would have checked where the positives were Well, anyway, moving
Are
on.
the brackets important on that? Given that we open?
Good question. This specifically asked on what open intervals. So you want to have definitely the round brackets. I can't tell you for sure if they would mark you down for a square bracket on that, because it would be considered not following the directions, but they also make decisions as they grade and decide what they're going to let go of and what they're going to expect.
Okay, thank you.
Uh-huh. All right, moving on to part D. Find the x coordinate of each point of inflection of the graph of f. I'm going to give the reason first because that allows me to be done with the correct explain and know where I'm looking and what I'm looking for. F has a point of inflection. Come on, like, really, you're just going to keep doing this to me. Breathe. Point of inflection. There we go. Happens when F double prime changes sign. That is the big thing you are looking for. Had I still had my charts ready to go, I could just look across my F double prime chart that I had made. F double prime is G prime. G prime is slope of this graph. So when the slope changes. Now, the slope to change at one point does not mean changing from being 0 to being positive or changing from 0 to being negative. It is a moment of change. The only place that it actually changes directly is 4. And real quick, I'm just going to write out what I would have charted for my F double prime, just so you can see what I mean. I had looked at slope and gone 0 slope, positive slope, 0 slope, positive slope, 0 slope, negative slope, positive slope. The only time I have a moment of change in sign okay, is right here. Everything else is changing from 0 to a positive or 0 to a negative. And then I'll just show the answer real quick. Okay, any questions on that problem? Yes.
So for part C and D, do you have to correlate the F and G together, or can you just say like when F prime is greater than 0 and F double prime is greater than 0, or would you have to connect it back to G?
It's best if you connect it back to G. But if you have already connected their relationship, they should look at that and accept that.
Okay, so if you've already explained it in like the past problems, that's okay?
Yeah. Yeah.
Okay. Awesome. Thank you.
Any other questions? I'm going to stop the recording.